This is the demonstration for the operation on signals. So the operation on amplitude signals, I have here the exponential signal, unit ramp signal, sinusoidal signal, sinc function, and triangular function. So each of these signal has a property. The exponential signal has an alpha equal to -1. The unit ramp signal is a first quadrant or R of t. The sinusoidal signal has an amplitude of 1 and period of 10, the same with the sinc function and the triangular signal. Let's try the exponential signal added to y of t equal to 0. So the original signal is green, added to y of t equal to 2. This is now the signal after an operation colored blue, that is 0, 1 plus y of t equal to 2, that is 3. You can also select y of t equal to 3 or y of t equal to 1. Next, we have the unit ramp signal added to y of t equal to 1. So the original signal is green, added by 1. The blue signal is the output. Let's try added by 2 and added by 3. Next, we have the sinusoidal signal added to 2. Sinc function added to 2. Triangular function added to 2. Then let's go to subtraction. So the green is now at the top side. From addition, blue is the top side. Subtraction, green is at the top side because it is now less than 2. Unit ramp subtraction, the green is the original signal. Subtraction and multiplication. If we multiply by 1, it is just the same. So you can select any type of signal, multiply to any or any straight line given in the program. You can also divide the original signal green is now half. Division. And now we have the scaling, which needs a scaling factor of 1. It will still the same. Scaling factor of 2, of 3, of 4, and 5. And next we will go to the operation on time signals. So let's try exponential signal. I have here the time shifting and scaling. It will require you to select left shift or right shift. First, let's try left shift of time shifting, and it will need values at the bottom. Now it will shift by 1. Or it will shift by 2, by 3, by 4 or by 5, or you can shift it to the right. Same with other signals. Next, we have the scaling. Let's try the sinusoidal with period of 10. So that is the scaling. And this is the A value. It means if the A value is 5, it will compress. And if it is less than 1, it will expand. Same with other signals. Greater than 1. Scaling is only applicable to sinusoidal, sinc function, and triangular function. On-time scaling is only for sinusoidal and sinc function. And greater than 1, that is compressed. Less than 1, expand. That is all for the simulation. Let's go to the callbacks of these buttons. So each radio button has a tag, that is expo for exponential signal, ramp for unit ramp signal, and so on. Sine, sinc, triangle right here. Sinc sine. This is Y1, Y2, and Y3. The tag here is slider num and scale. So first, let's go to the slider num. In the callback, we have the slider value. It will get the value of this slider num. After that, it will set the handles of scale or this static text with the slider variable. And next, we will go to addition callback. So these variables will get the handles of these radio buttons, and the condition that if B is equal to 1, that is the exponential signal, and BA equal to 1, that is the Y2. So first, this plot the X and Y, that is the added. So the original exponential signal has a variable of orig X and orig Y, and then it will undergo addition to 2. So this code is copied, replaced with variable X and Y, and instead of this, we'll add plus 2 to the Y value, so that it will plot the X and Y, will plot the original X, but the Y is added by 2 because of the condition BA is equal to 1 and our BA is Y of t equal to 2. So this is just copied for the rest of the conditions. So the other condition is b2 equal to 1, and b2 is that the unit ramp signal, and ba is the y of t equal to 2, y2, bb is y3, bc is y1. So else if b3 is equal to 1, the sinusoidal signal, that is the orig n and orig y, that is the original sine function, and I use this omega because that is just the default omega to the sinusoidal signal, and the plot of n and y, that is the y, is added by 2 because ba or y2 is equal to 1. bb or y3 is added by 3 to the y, bc equal to 1, that is y of t equal to 1, so that the y value is added by 1. So that is for addition. So the codes for the addition were just copied, and the only changes are that instead of plus 2, I made it multiplication. This goes for every condition. Instead of plus 1, I made it multiplication. It's also the same for subtraction. I copied the codes. Instead of minus 3, instead of plus 3, I made it minus 3. So these signals, exponential, unit, sinusoidal, sinc, and triangular, are copied from the previous laboratory. So these are the original signal and operated with addition and other operations. Also the same with division, same codes, but I changed the operation, which is division. And for the scaling, this is just the same with multiplication. Scaling, this is the scaling factor. The variable, it will get the handles from the static text. So this is the y scale, scaling of y. Next, on the time signals, this is the slider button have the same codes with the slider button at the left. However, the handles or the tag is different. Slider num3 and t value. So this t value is just for time shifting to determine the amount of units for the shifting. The callback is the same for the a value and also for the period. They just differ in the tag. The main callback or the main code for the time signal is the pop-up menu. So these variables will only get the value for the radio button and this from the slider button. If A is equal to 1, that is the time shifting, and B is equal to 1, that is the expo if it is selected, and BA equal to 1, that is the 1 or the left shift if it is selected. So that is just first it will plot the original signal of exponential signal, and using this code it will shift because shifted to the left from the x value of 5. It will shift because 5 minus the t value. So the main factor for this shifting is that the x varies by the value of the t value from the slider button. So this is just the same for the code. It's just that the x values are different. If you want a right shift, it will add the t value to the x. B5, that is the triangular function, and the else if a equals to 2, that is for the scaling, which is just multiplied by the a value for the sinusoidal and the sinc function. So that is for all the callbacks in this